I'm Ashok. Welcome to another video on Advanced Python for Data Science. In this video, we look into one of the powerful feature of Python, which is decorators. Decorators actually modify a behavior of a function or a class without actually permanently modifying it, It modifies from outside. So decorators modify the behavior of function or a class without permanently modifying it, without actually not tweaking permanently modifying it. Okay, what I mean to say might be more easy if I explain with an example. So there are a lot of aspects of decorators. There are concepts related in Python where you can call a function inside a function. A function can be passed as an argument. A function can be assigned to another variable, and then we can do a lot of stuff with functions. So I'm going to touch a basic concept of decorators and how it is useful. So let me define a function, a wrapper function. I call it as define calculate execution time. Okay, so this function is expected to calculate how much time taken by another function. So the argument of this function is actually another function. So I'm taking a function as an input. This is just an argument name, and when I pass a function to it, this actually gets that function. All right, so inside that I need to wrap another function, say wrap a function, and I'm gonna generically define the arguments. So these are arguments and keyword arguments. This is a most generic way of defining, so you can give any arguments to it, it will be passed as such. Okay, so we'll talk about asterisk args and double asterisk keyword arguments in another video. Right now, just just note that this is a very generic way. Can you pass anything to it and it actually comes into this, any number of variables, keyword variables and direct variables. Okay, so I'm going to calculate time, so I need this time package inside it. So I'm going to say begin time, or simply begin, is equal to time and time. I'm just taking the time in the beginning, and then time and the ending. End is again time. In between, I'm going to write down running of that function. So I'm going to say function, just pass on these arguments. So whatever arguments we provide to the function is directly passed on to it and it runs. So I can't define a function, at least not in a quick way and long. So I'm going to just put a sleep there, so that at least some 1 second, for example. So I just put 1 second. So there's a 1 second sleep, and then the function executes. So anything time taken the function is 1 plus that time. Just because the functions I'm going to write is really small ones, so it won't take much time. So I'm just putting 1 sleep there. All right. So that's it. So now I can define another function, which is any function. So let's say I'm going to define an exponential function which takes a number, okay, and then simply returns or prints the exponential. So I need a math for this, for example. So math, import math package, and say print math exponential and then number. It's a pretty simple function. So when I say exp of let's say 100, you get a very big number, as you can see, to the power of 43, 10 to the power of 43, a huge number. All right, and so as such, this function is a small function which just executes, basically prints the exponential value of any given number to it. Right? If I want to modify it, I want to actually also enable this function to calculate the time of execution. I can simply do that by using this decorator operation. So this is the ampersand, or at the read symbol, so you can just put that and say calculate execution time, and below that you basically define this function. So when you run the exact same thing this time, you see that, okay, there's some problem with that. I'm not returning this. I'm supposed to return this inner function, sorry. Return this inner function. Okay. So this is a simple one. Now I'm putting the decorator. 1 second, and then, okay, I did not print it. Yeah, I'm supposed to print this, isn't it? So let me print the total time taken is equal to end minus begin. Okay, this time it should run. Okay, let me explain what happened. So this is the exp function is a very simple function, takes a number, prints the exponential value of it. And I have another function called as calculate execution time, and has a wrapper function inside where I have simply put a begin time and end time, and in between I have run the function which I have taken as an argument. Okay, so when I say this is actually decorator function, decorator. So when I say the decorator, the function execute calculate execution time, this one with an ampersand, and then define a function underneath, what happens is this function becomes an argument for it. So essentially the exp function, the exponential function, which is this one, will become argument for it. So it becomes a function for it. So let me just the moving up and down, I'll just put it right here. So this function has become an input for this, and when it becomes an input, when this function executes, first it basically starts the timer and then 1 second delay, and then runs this function which is nothing but the exponential function, then captures the end time and calculates the difference and basically plots it. So when you run it, so you see that this function has taken 1.005 seconds. Essentially it is actually 0.005 seconds, but I have put 1 second delay, and it has said 1.005. and what you notice is we have modified the behavior of this exponential function, exp function, without actually changing it. I haven't changed it. I have taken this as an argument for another function and did whatever I have to do over a wrapper function. All right, and this is very powerful, and you may not appreciate it at this moment, but you'll see a lot of implementation, including whatever we've seen. For example, in the beginning of this session, we were actually looking at, okay, so we are looking at the data frame in a GitHub. You'll see a lot of implementation of data frame actually uses decorators heavily. All right, so decorators is one of the commonly used, and even if you don't use it as such, you should not get confused when you see this notation, like this notation. This essentially means that this is a wrapper function, another function which takes this function as an input and does something over it, mostly adding value. In our case, we have added value by just wrapping up to a calculate function which calculates the time of the execution. So essentially it took me 0.005 seconds to execute this. Let me put 1000. Might get a very big number. Oh, it's actually overflowing because it's too big. That also overflows. Okay, somehow we managed, and finally it actually took lesser time. So I guess this is too small. It's not really able to see. Every time you do it is even more small, 1003 seconds. It depends on many other factors. Also my CPU availability, maybe busy with something else. So it's a very tiny one. But if you really execute functions which has heavy computations, some deep learning stuff, it may take a lot of time. So wrapping up inside it like this will really helpful. Rather than modifying the function itself, using decorators to modify the behavior is a very powerful feature in Python. All right, that's all. So hope it is helpful, and if you have any further clarification, you can leave it on the comment. Thank you very much for watching this video, And if you like this channel, please subscribe and click notification button. I'll see you in the next video.